IoT has a great deal of coverage in the press and conversation around embedded world this year. There's a substantial amount of initiatives associated with IoT, including system consolidation and machine-to-machine functionality, or M2M. And it's the latter areas of this that we're most interested in, as it has related to us for quite a few years. The ability to scale systems and communicate effectively with some new dynamics that are developing, where people are looking at how do you communicate in a greater world of collaboration, and we look for the means to assist in guiding people towards solutions that are open and standards-based. And for that, we have a great deal of interest in, say, OPC as being a component within the greater solution. That's a good question. We had seen for as many years as we've been doing this, a relationship between Microsoft and OPC developing collaboration communications that have grown to 20,000 or more different products available for OPC. But it's always been restricted in that sense to the Windows domain, and with further advances in OPC UA, it has relaxed the requirements for what platform an OPC server could be on, and therefore the ability to be able to replicate the functionality into new areas, into smaller platforms, where the services could be used in a similar fashion, but also could be more tailored towards direct machine-to-machine functionality, where departing control and supervisory information back and forth is tightly coupled between different types of applications and operating systems. In fact, OPC is very easy to use. We've gone as far as implementing an OPC server directly into our InTime6 distributed RTOS, so that we can demonstrate how easily it is to integrate and deploy servers in systems which are not Windows-centric. This gives a chance for people to at least have a first touch and a means to then explore how it is that they might make use of publishing and exchanging information, either machine-to-machine for control and smaller groups of elements, or all the way through gateways and on into this IoT objectives of cloud-based analytics and the like. OPC was developed to provide for secure communications, and for everything associated with IoT and future communications, it's been very clear that security has to be taken as high regards in whatever direction someone goes to implement. There is a great deal of creativity and a great deal of opportunity available to create new standards from which M2M could be used, could be implemented. But the impact of using something which is already in existence means you could extend what's already been used and enhance it for applications where you previously could not put a server because of the limitations of what OPC was only within the Microsoft Windows domain. Now that it's free to implement a server on any platform, you can make use of the existing services that you may have had for just SCADA applications, but now driving down deeper, you can have servers and clients talk directly to each other from headless operations and communicate and coordinate effectively throughout a network of controllers.